Jarrell wants to know the height of the Ferris wheel. Let's go and draw a Ferris wheel. So he wants to know h from a given point on the ground. So here's my ground. You can even label it ground. It's helpful. So Jarrell wants to know the height of the Ferris wheel. Here's my Ferris wheel. He wants to know the height, so I label that h. And then from a given point on the ground, I've actually labeled where the ground is, and from a given point, you can call that p if you want to. He finds the angle of elevation to the top. So to the top there. The angle of elevation is 42.3 degrees. 42.3 degrees. He then moves back 75 feet. So going back 75 feet. So from point P, we'll call it P1 to P2, point 1 to point 2, from the second point, P2, the angle of elevation to the top of the Ferris wheel. So the same point up there is 25.4 degrees. Find the height of the Ferris wheel. Alright, as we think about this problem, I see two triangles, a smaller triangle. I'll call it the pink triangle. And then a green triangle. That includes the second point. And they're both right triangles. So something we do not know is from the base of the Ferris wheel to point number 1. That's an unknown, so I'm going to call that x. So when I draw my two triangles, so we got to separate our triangles now. Triangle number 1. And triangle number 2. So on the small triangle, I have 42.3 degrees. I have x. And I have h, the height. Notice how this triangle has two variables. Notice how in this problem it tells us find the height of the Ferris wheel. So if I need to find the height, h, I'm going to solve both of my triangles in terms of h. Let's label the second triangle. So this green triangle still have the height. Now pay attention. You're adding these two distances, x plus 75. And then that angle is 25.4 degrees. So here's these two triangles. Raise your hand if you have those two triangles on yours. Okay. So when you're doing like a problem like this, just back in geometry, separate the triangles. And you want the triangles to be similar. What does that mean? They're both right triangles. A common mistake is to draw the big triangle with these dimensions. And I'll even draw the mistake. And they write 75. Okay? They're going from this scalene triangle to a right triangle, and they just slap on 75. That would be wrong. let's go ahead and solve for this pink triangle. I'm starting here at this angle, cross-which trig ratio. Tangent of 42.3 degrees equals the opposite over the adjacent, h over x. Put this over 1, cross multiply. I have 1 times h, or just h, equals x times tangent of 42.3 degrees. Here I've just solved for height in terms of x. The next thing I'm going to do is on this triangle, I'm also going to solve for h. So I'm starting at my angle, tangent 25.4 degrees equals the opposite over the adjacent, h over x plus 75. If I solve for h, and this is also equal to h, I can set them equal to each other. System of equations, that method is called substitution. So if I put this over 1 and cross multiply, I'm going to get tangent of 25.4 degrees times the quantity x plus 75 equals h. Now I have two equations set equal to h. If you think about it, notice how I have two variables, and to solve two variables you're going to have to use systems of equations. Every time I see h, I can write x times tangent of 42.3. I see h over here, and every time I see h, what am I going to write, class? X times tangent 42.3 degrees. When you're doing those substitutions, I think colors are helpful, so if you can use those, great. So on this side, I still have tangent of 24.4 degrees times x plus 75. Now pay attention. Notice how when I do the substitution, I've eliminated the variable h, and I'm just solving for x. Is x the answer in our problem? Is this what we're trying to find?
No.
No. We can solve for x and then substitute into either of these equations to solve for h. In order to do that, I need to get the x's together. I'm going to show you a different method. So this is multiplication. No. This is multiplication, so I'm going to go ahead and distribute. I'm going to get x tan 25.4 degrees. And this is plus tan 25.4 times 75. So that becomes 75 times tangent of 25.4 degrees. And this is the same. I'm going to subtract this expression to the right side. The reason why I'm doing that is I'm trying to get the x's together. So if I subtract this, this will cancel. I'm left with 75 tan 24.4 degrees equals x tan 42.3 degrees minus x tan 24.4 degrees. I'm going to factor out a GCF. Everyone say GCF? GCF. Notice how they both have an x. So now I have x times tangent of 42.3 degrees minus tangent of 24.4 degrees. This side we can actually evaluate it. So now I'm going to put it into my calculator. (75) times tangent of 25.4. Make sure you're on degree mode. That's the degrees in my calculator. Alright, now some students ask, Mr. Ring, I'm off by a couple of tenths or hundredths on your calculations. It's here that they're probably rounding. So if you're off by a little bit, go back, and wherever you've done a problem, I would try not to round. So I'm just going to round here, 3561. The next thing I'm going to do is now move all of this away from the x. And you cannot subtract the angles. You cannot do 42.3 minus 25.4 and then press tangent. That'd be incorrect. They call this the difference identity of tangent. So now I'm going to divide this whole expression. Just coming back on this side. This will cancel, and we're going to get an answer for x. So in our calculators, I'm just going to take my answer and divide it by these two. So I have an answer in my calculator, so even better, I'm not even rounding. And I'm going to press divided by tangent of 42.3 minus parentheses I want to go back and insert another set of parentheses just in case. So tangent 25.4 parentheses parentheses. And here's a way of double checking. Notice I have the arrow there, which means that you can go to the left, so just keep pressing left. I have 1, 2 parentheses, 2 close parentheses, 2 open parentheses, 2 close parentheses. I'm going to press enter. Raise your hand if you got 81, 85. Let's write that down. Now, class, did we say x equals 81, 85? Did we say that was our answer? No. Once you've solved for one variable, you can choose where you're going to put that x. You can put it back into this green box, or you can put it back into this blue box. I'm going to choose the pink one. Doesn't matter which one. It's just this one has less math to do at the end, less computations. So now I'm going to write, for my value of x, 81, 85 times tangent of 42.3. And again, notice how I still have it in my calculator. I'm not even going to touch the calculator. And I can just press divided by tangent 42 0.3. And you're going to get approximately 89.95. I was going to say. Let's go back. Watch what I can do. So this is incorrect because I did division and we needed multiplication, so I can just press second enter and my answer pops up again, but then I can go back and actually edit my command. No. Try that again. 81.85. It went back to the original one. 81.85 times tangent 42. Now I'm going to get 74.47. And if you notice, all of my answers, notice how all of these are 2 significant digits and rounded to the nearest ones. Does that make sense? So I can put here 74.47778 if you want to, and then you can just say approximately 74 feet. Raise your hand if you got approximately 74 feet.